Welcome everyone to our first video in the series Equal Triangular Areas. And the purpose of this series is exactly what it looks like and sounds like, finding areas, equal areas especially, in triangles. And the triangles do get more and more complex. But before we get to any problems yet, I would like to talk about the key sentence, the conclusion that we're going to be playing around with every single problem here. And that one is written in bright yellow. So any triangle side length relationship is equal to the same triangle's area relationship. So here's what I mean. Say we have two triangles. And they both have the same base, 2. And their heights, well, one is A and another is 2A. So basically means that the triangle's height, so triangle number 2's height is 2 times that of triangle 1's height. So what this means is that for the area, it would also be times 2. So basically, what we're saying is if the base of your triangle is, say, times 3, then the area would also the area relationship would also be times 3. If your height is times 2, then your area relationship will also be times 2. So I think now you get the idea. And okay. So now that we've explained what this means, I'll just set this to small mode. Okay. And so we have more space for the problem. As shown, triangle ABC has an area of 40. And points D, E, F are each the midpoints of BC, AC, and AD. So we're trying to find the area of triangle DEF. Triangle DEF. So let's first think about how we can use this conclusion right here to help us solve this problem. Well, we know the area, the whole triangle, so ABC has an area of 40. But so far, I'm not sure how that can really help us to solve the area of DEF. But what we do have is midpoints. Now, when I say midpoints, you should immediately think that the line it is the midpoint of, so in this case it could be BC. D is the midpoint, which means that BD and DC are equal. So is AE and EC. I'm just using different shapes just to show you that they're equal, and for this I'll use triangles. So something else that a midpoint might remind you of is going to be the fraction 1/2. So midpoint is a very, very important key point here. So let's first think about how this now can connect to this. Well, 1/2 is a fraction, and fractions are relationships. So we know that when calculating this triangle's area, right, we need to have the height, and we need to have the width, which is also called the base sometimes. And we will notice that the height and the base is 1/2 that of triangle ABC because of the midpoints. There are 3 midpoints, but we only use 2 of them because we only have 2 parameters. One is base, one is height. So we have 1/2 times 1/2. Okay. And then So this is our relationship. Okay, this is our R. So I'm gonna write R for relationship because it's very important to really understand what each fraction is equal to. But remember, if we just do base times height, it would equal a rectangle. And we're not looking for a rectangle, we're looking for a triangle. So we still need to times that 1/2. Remember, the area of a triangle is base times height times 1/2. So this is just that 1/2 right here. And okay, so this is our relationship. This is how we calculate the area. Now we just Now we just find the area. Now we just take this relationship and we're going to multiply it with 40. Because 40 is what this whole triangle is, this big triangle ABC. And this is just a relationship that DEF has with the area of ABC, which is 40. So it's equal to 1/8 times 40, same as 40 divided by 8, so 5. So the area of triangle DF is 5. So it's really a good idea to remember this very important conclusion right now. If you have to, you can write it down. But it's really simple. I mean, you can even test it out yourself and conclude that yourself. So it's in another key point of this problem was to really pay attention, and especially for me, I highlighted it. You can underline keywords if you don't have a highlighter. And I really thought about what the keyword midpoint means. So the two numbers but especially 1/2. So the two numbers that immediately came to me was 2 and 1/2. But right now we're talking about relationships especially. So I kind of focus more on the 1/2. Also, just another tip, it's very, very important to really know what each fraction is representing, what each number is representing, because as we have more and more numbers later on, you might lose track or you might get confused. So it's really, if you have to, you can even just label it or just have a really clear understanding of what you're doing. So thank you for watching problem 1 and see you in the next problem 2.